Inside the boxes of a new brand of cereal is a short survey that can be mailed back for free to the manufacturer. The survey asks the consumer if he or she likes the cereal or not. What, if any, will be the most noticeable bias for this survey? Well, since you are giving it to people inside of the box of cereal, it's only being given to people that probably like the cereal already. Or if they don't like the cereal, how many times would they be buying it to begin with? They wouldn't be buying it that often. So the only type of noticeable bias, anyway, noticeable, keyword there, is that this would be a sampling bias. As again, the people that are probably eating the cereal more than likely like the cereal already. And you wouldn't be asking too many, if any, people that don't really like the cereal. Unless this is, for example, the first time buying it or it's on sale or something. But the biggest idea of it, though, is if you're eating the cereal and you have a brand new box, you probably like it already. Question number 18. So a new roller coaster and amusement park requires individuals to be at least 4 feet 8 inches tall, or 56 inches, to ride. It is estimated that the heights of 10-year-old boys are normally distributed with a mean of 54.5 inches and a standard deviation of 6 inches. We want to know what proportion of 10-year-old boys is tall enough to ride the coaster. So, for something such as this, we want to use, so for this, we are going to take, so this would be the probability that we have a value greater than or equal to 56 inches. So for this, we are going to take, and we could draw a very quick version of it, but the mean of this was 54.5, and 56 is over here. So for this, we want to find the probability of this occurring. So this is going to be equal to, in Excel, 1 minus norm dot dist of 56, 54.5, 6, and true. So popping that into Excel over here, let me very quickly model that. 1 minus norm dot dist of 56, 54.5, 6, and true. This is going to give us a probability. We want this to 4 decimal point values, so let me expand this out a little bit. There we go. This gives us a probability of 0.4013. So to write that as a sentence explanation, the proportion of 10-year-old boys tall enough to ride the coaster is 0.4013 according to this model, since it's normally distributed to begin with. For part B, we have the smaller coaster has a height requirement of 50 inches to ride. What proportion of 10-year-old boys is tall enough to ride this coaster? Only difference between these two is this is going to be a 50. So, and that was a very strange occurrence, I know. So, for this, we want the proportion of 10-year-old boys tall enough to ride the second coaster. So just like the one that we just did, instead of Excel, we're going to want to type. Let me just write that down here. This is the probability then that we have an x value greater than 50. And we're going to do 1 minus norm.dist of 50, 54.5, 6, and true. So I'm going to, I'll put it right here. You know what? I'll keep it here. This will give us a value of 0.7734. So yes, this value should be greater than the last one. The interpretation of this is that the proportion of 10-year-old boys tall enough to ride the smaller coaster now is 0.7734. Okay. And then the last one of these is the proportion of 10-year-old boys tall enough to ride the coaster in part B, but not tall enough to ride the coaster in part A. So, for something like this, okay, and you can imagine it. If this is actually a pure normal distribution, not the bad one that I just drew, with a mean of 54.5, we have the value of 50 kind of over here to the left, and 56 over here to the right. We want this area between the two. So, for this would be the probability we have an x value between 50 and 56. This is going to take, because Excel gives us area to the left, this will be norm dot dist of 56, 54.5, 6, and true, minus norm dot dist of 50, 54.5, 6, and true. And that's a very bad U. Okay? So, tossing that into Excel, and let me quickly model that. So, norm.dist, 56, 54.5, not comma, 54.5, 6 and true, minus norm.dist of 50, 54.5, 6 and true. Okay, so you would type into Excel as such, and you get yourselves a value of about 0.3721. So 0.3721. That's a very bad one. So the interpretation of this particular interval is going to be, let me just type E. Let me very quickly type this into here. This would be that the proportion of 10-year-old boys tall enough to ride the coaster in Part B, but not tall enough to ride the coaster in Part A is 0.3721. For question number 19, we have, for a test of the null hypothesis where the proportion is equal to 0.50, sample proportion is 0.43, based on a sample size of 100. So that is going to require the one proportion z-test. We first want the test statistic. So here we have ourselves a sample size of 100. We want a proportion of 50%. Sorry, a proportion of 43%. So we're going to type in 43 here. And we are basing this on a value of 50%. So the test statistic for this is negative 1.40. The p-value for a probability less than 0.50, we could see is 0.081. That's a very bad E. So 0.081. And then does the p-value in B give much evidence against the null hypothesis? So for this we could type that conclusion out. The p-value does not give strong evidence against the null hypothesis. The p-value indicates that the null hypothesis is plausible. That's due to the fact that the p-value is greater than the level of significance of 5%. For question number 20 here, I have, suppose the data for 57 randomly selected female high school athletes was collected on the maximum number of pounds they were able to bench press. The data are roughly bell-shaped, with X bar being 74.7 and S being 13.8. We want to use the empirical rule to describe the distribution. So, if you recall the empirical rule, 68% of the data is within one standard deviation of the mean. So this would be 74.7 plus and minus 13.8. 95% of the data is within two standard deviations of the mean. So 74.7 plus and minus 2 times 13.8. And then 99.7 are all, or nearly all, is within 3 standard deviations of the mean. So this would be 74.7 plus or minus 3 times 13.8. So to type all of this out, we have some nice sentence structures. This is going to be approximately 68% of the observations fall within the interval. So 74.7 minus 13.8, that makes 60.9. And for 74.7 plus 13.8, that makes 88.5. Approximately 95% of the observations fall within the interval 74.7 minus 2 times 13.8 gives us a value of 47.1. And if you did 74.7 plus 2 times 13.8, it's 102.3. Then all, or nearly all, which is that 99.7, of the observations fall within the interval 74.7 minus 3 times 13.8 gives 33.3. And if you do 74.7 plus 3 times 13.8, you get 116.1.